A very good evening to Dr. Jivaraj and our member, Ms. Chu Bunwei. Yeah? So today is our presentation for APOD, Astronomical Society of Penang, our monthly astronomy picture of the day by NASA. All right. So today's session is hosted by Chu Bunwei, our member. I'm Dr. Chong from the Astronomical Society of Penang. I just introduced our two members. And so, by the way, Dr. Jivaraj is based in Ipoh, and Bunwei and I will be in Penang. Okay, just for you all know, Penang and Ipoh are south of Thailand and east of Sumatra. All right, and so we can start now.
Okay. All right. I'll start with mine. All right.
Yeah, we see our screen.
Yes. Okay. Now this
2nd of July.
Yes. Now this is the oyster star cluster.
Wow.
It's incredible. It's incredible. It's actually a composite overlaid on it by images taken in X-ray by the famous Chandra Observatory and the Spitzer in infrared. So this is what it looks like in infrared. Now the purplish haze, infrared, X-ray, this thing, and you can see the stars practically light up, some which are not visible over there, and they show up as X-ray sources and so on. Now the oyster star cluster is because it looks like an oyster just freshly opened with some pearls in it, so that it derives its name from that. And now you'll find that there are a cluster of hot blue stars, which is actually giving off electromagnetic radiation, X-rays and so on, which is actually driving the dust of the nebula away from it, okay, and giving rise to ridges and pillars and so on. And you'll find that rather than the nebula itself giving rise to the stars actually were formed within the nebula, and its energy is driving off this nebula spread out. Now, what's interesting about this particular nebula is it's in the small Magellanic Cloud. Now, we don't have to go far to look at galaxies. We don't have to look at Andromeda to study it. We have our own neighborhood galaxies just next door, which is the small and large Magellanic Clouds, which are irregular galaxies accompanying the Milky Way. Just like Andromeda has got its sister or daughter nebula galaxies by the side, so do we have. And it's interesting that in this one, we can actually study phenomena which is just next door, and therefore try to extrapolate the star formation, the energies involved for further study in this thing. And you see here there are pillars being driven off and so on by energy from these stars. There's actually this is supposed to be in the wing of the small or lesser Magellanic Cloud, which is so-called mineral deficient of it. And there's a lot of research going on about the formation of stars in a mineral deficient what do you call it, nebula. Mineral deficient, according to astronomers, is anything more than atomic weight 2, which for us, of course, is pretty light. So apart from helium, hydrogen, all the rest is considered as mineral rich. Okay? And it's incredible. You can also see, as you look in over to this side, you can actually see galaxies which are much further away, but it's in our line of sight. So it looks as if they're there. There's an irregular elliptical, there's a spiral, and it's an incredible picture just by itself. Chandra, of course, was the grandfather of all the X-ray telescopes around the place, and he's done a lot of discoveries from it. And the Spitzer is a fairly newer one. Okay. Now, that's about this. My next picture is this one.
Nice name.
Another nice one, Caroline's Rose. Now, in a small telescope, this one actually looks with all these dark lanes there, here, and this spiral group of red, orange stars, hot stars. They look like the petal of a rose, and therefore it's known as Caroline's Rose, because it was discovered initially by one of our famous astronomers, Caroline Lucretia Herschel, who is famous for being the sister of Herschel himself. Okay? Who's also well known as an amateur astronomer in his time.
Yeah.
Now, it's an open cluster, and these are the red stars, and you get some blue stars sprinkled around them. And the giants are, of course, larger stars which have consumed their nuclear fuel and are now expanding into red giants, okay, having evolved from the main sequence. And yes, it's over 50 light years across. I think in a telescope, a small telescope, it should be a brilliant sight. Okay, that's on that. And by the way, this was taken by an Italian, Massimo Diffuso, who is an Italian chemist and an amateur astronomer, and his pictures are incredible. He's got a web page, and if you go there, you'll be able to see incredible shots that he's taken of the cosmos. And it's really a wonderful showcase of his dedication and his interest in astronomy.
So, Dr. Jiwa, just to add on, so in the history of astronomy, we know William Herschel, Caroline's brother, is famous, but we know that both William and his sister Caroline originally came from Germany. But for some reason, they migrated to England. Famous as English astronomer, but originated from Germany. Yeah.
Yes, that's right. They originated from Germany. The brother went first. I think the sister joined later in England. Yeah. And she was the first astronomer, if I'm not mistaken, or rather female astronomer, who was actually paid for her job.
Yes.
Yeah, she got a monthly pay just to be the royal astronomer attached to the observatory.
Yes.
And her discoveries are just equally as famous as William Herschel's discoveries.
Beautiful.
Now the next one would be this one. Ooh, just look at that.
July.
Yes, the Crab Nebula. Oh, it's wonderful. It's fantastic. You have taken again by Hubble, Chandra. You have X-ray emissions. You have X-ray light and visible light. Okay, the red and blue is visible light. This by Hubble. Okay. And X-ray light shown in white, and the purple is by the Imaging X-ray Polarimetry Explorer. I think another form of looking at X-rays here. Now, a history behind this. Now, when it was predicted that Hubble, that famous comet, Thought Block.
Halley's Comet?
Yes. And Halley's Comet was supposed to come around this time in the past. Messier was one of them who was looking for it. And the postulated direction was somewhere where the Crab Nebula was. So when he first saw it, he thought, oh, that's it. That's the comet. I've got it. But it didn't move. It was fixed. And then he realized it's not the comet. He had made a mistake. And he had a thought, okay, let me just catalog all these objects which are interfering with my search for comets. Okay. All this disturbances, this nuisance. And so he started with this one, and this is M1. And in fact, now he's more famous for his Messier catalogs than for the other discoveries with comets that he had done. Okay. Now, the background of the comet of this nebula is, it is discovered quite early by the in ancient times. I think around the 1054, also by the Chinese, who actually noticed what do you call it, a guest star during the day.
Yes.
In 1054. In 1054, they actually discovered a guest star. And it was visible during the daylight, okay, which means pretty bright. It was visible for almost a year or so. And it was also recorded in certain Egyptian this thing. And it's one of the first or earliest examples of which is linked to a known astronomical object. It's one of the earliest. And the Crab Nebula is actually a supernova remnant. Okay? A cloud of gas and dust being driven forward by the power of the supernova, and it's actually collapsed into this central white dot, which is a pulsar or a neutron star, which is rotating so fast, and that as it emits radiation from the poles at an angle, it actually blinks. So this radiation that's going on from the pulsar or rotating neutron star is actually slowing down. As the spin decreases, the energy loss is shown by the power used to drive this nebula away, or rather apart. Once in a while, they have a sudden loss in spin due to what they call the glitches. So the neutron star actually shakes, slows down sharply, and then releases massive amount of energy, which actually causes the nebula to increase over a matter of days. Astronomers have observed that they can see the changes over a matter of days, and then it goes back to its slow decaying spin. And the nebula, over the years that it's been studied, has actually been shown to be expanding. And it's fantastic. It's one of the earliest discoveries of a pulsar, a rotating neutron star. It's one of the earliest examples where you can link historical records with a known, actually ongoing astronomical phenomenon right now. And it's somewhere near the elliptic. So a lot of objects which go in occulted and have been used to, it's been used to study their properties as well by the amount of occultation of the pulsars and light as it comes to us. Now, it's really an incredible picture. There are even more wonderful pictures that you can see from the web where different aspects of the X-rays are actually photographed. And it looks like an electric storm. It looks just like an electric storm rather than a crab. Although when the early astronomers like Ross and so on imaged it, they drew diagrams that look, it looks like some kind of a claw reaching out, and they said, well, that looks like a crab. See? If you have a smart telescope, even a sea star or Vespera and so on, you can actually see this incredible, this thing, like a spiky cotton wool with lines across it, and it actually lives up to its name as a crab nebula. So to sum up, it's one of the earliest examples of known astronomical phenomenon from the hundreds, 1054, I think, initially noticed by Chinese astronomers in daylight and even in night when it was visible for almost a year plus, I think. And then it's been slowly linked to this. And how they linked this to that event was, as it expands, they're able to sort of, okay, let's go backwards. And it's expanding, let's contract it all down and they come to a point source in time. And when they looked at historical records, they said, oh, this point source actually corresponds to what the Chinese astronomers said. And for something, that point source to be so bright and so visible, there's only one phenomenon in the universe, and that is a supernova. So that's about the Crab Nebula. Very, very, very nice picture. Lovely, lovely picture. And a very nice history behind it. It's interesting to read up about the Crab Nebula. M1, there's a lot of history and interesting facts around it. Now my next one would be
Today's picture. 28th of July.
yes, that's right. Sundance. Okay. Now, of course, we know that the surface of the sun is actually boiling, literally boiling, just like that. But if you look at it, it seems featureless, and even when you observe it, you see static solar prominences, which are actually loops of magnetic field, whereby the corona actually goes around and comes back into the thing, and they last for days. And once in a while, these coronas actually detach from the sun and detach from the sun's surface and eject masses of plasma in mass ejection event. Now, this one is one very fast one which occurred over a matter of hours, and it's a flowing arc of prominence that goes on and comes back into the surface of the sun. It's huge. It's huge. The Earth can actually fit under there, somewhere about there, right? And look at it. This one.
Fantastic.
Oh my! Just look at that. Just it's fantastic, fantastic video and this thing.
Yeah.
One more time. Here it comes and then it goes down in a loop. You see, if this loop instead of going there detaches and goes upwards, then you have a solar flare with a coronal mass event. Now it's a fantastic picture and video, and it just goes to show that sometimes, even if there are clouds, you can always study our own sun and enjoy lots and lots of events that you can and interesting things that you can see. In fact, there's one amateur astronomer in Malaysia, I think, is Kiran, who's posts a lot on Facebook, and his solar images are incredible. I think he concentrates basically only on the sun, and the pictures that he posts are really world-class pictures. Very, very interesting pictures. So, I think that's about it for me. This thing. Yes.
Thanks, Dr. Jiwa and Boon Wei. So any comments from both of you? Any final comments? Yeah. Of course, I would like to thank our member, Mr. Lai, who selected these 8 pictures. Very good selection, right?
Yes, yes. Very, very nice selection.
Yeah. He will select so that there's no overlap between this month's presentation and the previous month. And the same month, there's no repetition. And he wants to bring some fresh information each time for every month. Yes. So we cannot look at any questions from our people who view this thing because we are not live. But it's okay. We'll post it in our YouTube channel and our Facebook page later on. Okay.